Welcome, everyone. So, Anthropic recently published a report called Disrupting the First Reported AI Orchestrated Cyber Espionage Campaign. And it generated a lot of buzz in the industry. So, this session is an attempt to do a deep dive into the report itself. So, if you have not read the report, you're just fine. We're going to go through the entire content. There's a lot of, I would say, concerns as well in the community, which is it the is it just hype? Is it they're over exaggerating the findings and so on? So we'll go through all of those in this session today. So thank you everyone for joining. I think the first observation I had was the use of the word cyber espionage. So typically, when we say there was a nation state cyber attack, or we'll say corporate cyber espionage, but the word cyber espionage does raise a little bit of flag. Like, why? So maybe one guess I had was that maybe the attacker motivations were stealing national security relevant information. That's why they're calling cyber espionage. But again, it's fairly unusual, the use of the word cyber espionage. Some of the key points of this report were that the use of agentic capabilities of AI. So typically when we use AI, we ask AI questions and it will give a summary or it will give us main points, and then we'll basically use as an efficiency tool. In this report, Anthropic claimed that basically it was close to autonomous. And that's, I would say, the novel point in this report. In terms of targets, there were roughly 30 global targets. So it was not limited to US only. It was a global campaign. The success rate was a small number for orgs. No firm number was indicated. By Anthropic, that how many of these organizations got impacted. If we look at categories, which one they were across multiple countries, it being a global campaign, so not just limited to US. It was large tech companies, financial institutions, chemical manufacturing companies, government agencies. I think the only thing which I felt was missing was defense tech, which is very interesting. Like, how come like defense tech if it was a really cyber attack campaign? The second question was who detected it. So it was not customer reported. It was not detected by a three-letter agency or like a researcher, but it was detected by the threat intelligence team at Anthropic themselves. They do have a safeguards organization. And other question was like, how did it even get detected? So we'll talk about a little bit like how Claude was jailbroken. So it was role play where the attacker were trying to say that we are a security testing company doing security research. But if you keep on doing it for a long time, it would raise some flags. So this is how the detection happened. There are no signals per se, like in terms of that you are having very large throughput, your API limits are being reached, but it was the detection happened because of sustained role play. From a timeline perspective, again, this is important. It happened in mid-September. So the report came just 2 days back, November 13th, but the actual campaign happened in mid-September. So before they published the report, it has been some time. Make sure, yes. And again, these are some observations. So wherever you see the person with the hat, those are my observations. So I think the first question I had was like, how did Anthropic came to this conclusion that it was only 30 and not more targets? And especially if the TTPs, which is techniques, tools, and procedures, are completely different, and maybe there are more undetected cases. Again, something food for thought. The other thing which has been talked about is how come there is no third-party validation, which is Anthropic's our investigation. So typically when you have this kind of breach or incident, you would typically involve the likes of Mandiant, CrowdStrike, and so on. But in this case, it was only internal investigation. So no third-party investigation. Our investigation validated. So this is again highly unusual. And also when you use third party, they go through a lot of things and provide you a definite confirmation that this is, did you have a breach? This was the scope, these many assets got impacted and so on. Also, since some of the attacks were successful and these were large tech companies, some of them might be public, and they would have breach notification requirements. And we haven't seen any breach notification so far from any of the large companies. So again, raises a little bit of flag there. Everyone with me? Give me a thumbs up. Very nice. Some other observations. So Anthropic has something called a responsible scaling policy. So I shared a Anthropic security references, and it has their responsible scaling policy. It is a very good read, so I highly recommend that you read it. And it talks about that how Anthropic in particular is trying to move towards additional what could be called AGI in a responsible way. And there's this concept of AI safety level or ASL. And as per Anthropic, they are at ASL level 3. So I think that raises the question that as per ASL 3, which is literally like one less than the highest, there's a talk of degrading functionality upon detection of malicious activity. And that doesn't seem to have happened. And also, the other observation was if there were nation state level attackers, what procurement guardrails have they put in place or are going to put in place? So typically, when you have an incident, people will do like a postmortem and provide their customers a report. So I think look forward to see in terms of customer verification, identification, what other controls Anthropics puts in play. Okay. Very nice. Threat actor attribution by Anthropic. So this is actually very interesting. They called the group GTG 1002. And again, this is the designation which was given by Anthropic themselves. So this is, again, very unusual, not standard. And again, the question is, if there's GTG 1002, is there a GTG 1001? And this doesn't meet industry nomenclature or what other have done. And the other thing I felt was typically sometimes people will name things. For example, I said that the Navy SEALs Team 6, there were not 6 teams in the beginning, but they called it 6 teams, assuming so other people assumed that there are 5 other teams. So I'm not sure about this nomenclature 1002 mean here. Again, no public information on GTG 1002, which basically Anthropic came up with themselves. MITRE does have a nomenclature, but it starts with G, it doesn't start with GTG. CrowdStrike has something called an adversary universe. So there's a screenshot there. So they have these 5 families: Cascade, Glacial, Aquatic, Mustang, and Operator. That's not there. Google has done a great job at coming up with doing an analysis of all the APT groups from China. Again, there's no mention of GTG 1002. Again, highly non-standard and unusual. Observations. So this is very interesting. Like, how did you attribute? And attribution is one of the toughest challenges in security. It was not in the report, but I came across an interview from Cyberscoop, which was done with Jacob Klein, which is the Anthropic Threat Intelligence team lead. And he said that the infrastructure and behavior overlaps with previous Chinese state-sponsored actors. The targeting set, they do target specific set of industries. From the Chinese, there's a mandate from the Chinese Ministry of State Security that these are the industry, these are national security goals in terms of IP or other. So that was one. Second thing is is very circumstantial, which is that the attackers would basically follow a timeline like a bureaucrat, like 9 a.m. to 6 p.m. They didn't work weekends. So again, it seemed if it was like a normal hacker, they don't care. You work late nights, you work on weekends. But someone working 9 a.m. to 6 p.m. like a clockwork and not working on the weekend shows that it was like a paid entity. Second one was that there was a Chinese holiday and there was basically no operational activity during that holiday. So again, fairly circumstantial. And Chinese state actors are very stealthy. They don't make any noise. They do the job and they get out without making noise. It has very unusual, but they also contract this kind of work to non-state entities. So it could be the work of a non-state entity, or it could be actual people employed by the Chinese Ministry of State Security. Okay, everyone with me so far, give me a thumbs up. So, what did Anthropic do immediately? They launched an investigation to understand scope. So, this is typical incident response. They took about 10 days to map the severity and full extent of the operation. They identified malicious accounts, they banned them, and the affected entities were notified. They notified their industry partners. So, again, this is very interesting. They do have knowledge sharing agreements with certain parties. So, it was not all across the industry, but companies or partners they have information sharing agreements with. And they coordinated with authorities as actionable intelligence was gathered. And after that, what they have been doing, they expanded their detection capabilities for novel threat patterns. Again, they haven't gone in detail, which is what exactly they do. They buy new tools, or these are attack patterns, classifiers. It's not very clear, like what exactly they did and they have done from a technical controls perspective. And they incorporated the attack pattern into broader safety and security controls. They're also prototyping early detection systems for autonomous cyber attacks. And they're developing new techniques for investigating and mitigating large-scale distributed attacks. And again, these are good pointers as to what others can do in terms of protection against such attacks, because they're attacking Anthropic today, tomorrow they're going to come after your org. Some observations which I had, which is they haven't shared any indicators of compromise. They haven't shared any initial access vectors. What will the exploitation chain look like? What were the TTPs? So the report is really lacking on technical details. And this has been the concern of many people who are in this domain. How did they detect? What current classifiers they're using to flag malicious activity? And as I said, they have shared only with people they have information sharing agreements with. They haven't shared with every major vendor who's in the detection space or is developing AI security stacks. Or we don't know if they shared it with other AI frontier labs like Meta or OpenAI or the new AI security startups. And I see a lot of like these founders making noise. So I'm not sure information was shared across the whole industry. The question comes like why did this happen? And basically these were new capabilities from Claude and Claude 4 in particular, where new models can follow complex instructions. You can do sophisticated tasks, especially like software coding. The whole agentic model, where you can have certain actions performed in loops, you can take autonomous actions, you can do chain together tasks. You have this chain of thought process. You can say, do this, then do this. And also you can have certain level of autonomous action as well. Tools, integration with software tools. So this is very interesting and we'll talk more about it. So Anthropic has something called the MCP or the Model Context Protocol, and in which a client or an agent can interact with multiple tools via almost what we call a middleware, which is the MCP protocol, and perform multiple actions. So you don't have to write integrations. The agent doesn't have to write integration with every single tool. Basically, the agent is integrated with the MCP server, and the server is integrated with a lot of these tools. And you can change actions among these tools using the MCP protocol. Now, major thing was that Claude was jailbroken. And as we mentioned, it was primarily through role play, in which the attacker said that, oh, we are an employee of a legitimate cybersecurity firm. We are using you for defensive testing. But again, they also got caught because of the same issue, which is they just kept on doing it again. Sustained role playing got them caught as well. Attack was broken down into small, innocent, routine technical tasks through carefully crafted prompts. And again, these prompts haven't been shared, so we don't know what were the exact prompts where they were able to break the safety guardrails of Claude. Tools used by attackers. So this is very interesting and also very important because the focus of this attack was orchestration of open source pen testing tool. So there was no new custom malware development. It's basically we are using the existing tool set and a person performing these tasks one by one, we can chain them together, we can orchestrate them together, and we can launch these attacks, and we can also do it parallelly. So this is, again, the parallelism is also very interesting, that these attacks were launched at multiple entities in parallel. So there's no custom malware development, no new tool development. The other novelty is the development of the framework itself. And we'll talk more about it, especially when we say how much of it was really autonomous. And these are some of the tool categories: remote command execution, browser automation, code analysis, testing framework, callback communication. And we'll talk a little bit more about callback communication. What does it really mean? So one observation I had was that if they used existing open source tooling, how come it didn't get detected? Because if you look at existing security controls, so for example, take a WAF, they would have prevention against fuzz testing, or someone is trying to do a SQL injection, or is trying to do recon, any malicious IP, any repetitive behavior, any concurrent sessions, which are very high frequency. So existing security tools do have controls against open source tooling. So it's not net new. They already see these attacks. They already see these probes on a daily basis, and they have appropriate detections built against these open source testing tools. So the question is, how come this attack was not prevented, either from a detection or prevention perspective? So again, we don't have clarity from this report that nothing new was done. It was open source testing tool, and we already have tools which protect against. So what's new here, and how were the attacks even successful? If we talk about attack lifecycle, so this is the typical attack lifecycle, nothing new here. So again, from recon to vulnerability discovery, then you exploit, then you lateral move across the infrastructure, you start saying, you're doing analysis. Once you have done exfiltration, what is important, and then you exfiltrate. And I think then the novelty was that all these were sequenced, and basically the response was adapted based on the previous phase. So it was a little bit, we figured out this is not working, so we will move only with the subset of data to the next phase. And that's where a little bit of the human intervention came into play. Automation. So again, that's the claim from Anthropic that 80 to 90% of the attack was automated. And this is being challenged in the industry, is how come you're coming with this number? Do you have any computation methodology which says that 80 to 90% of attacks lifecycle was automated? So basically, there were multiple instances of Claude code, and which acted as autonomous pen testing orchestrators. So the main job of Claude code was to orchestrate this attack and act like an agent to actually perform the testing. And when these agents were interacting, they appear legitimate because they were being evaluated in isolation. But if you look at the whole attack together, this is a malicious active attack going on. And in this one, basically, you have to maintain context, like what's really going on, which phase are we in, and you aggregate results from each of the phases to the next phase over multiple sessions. So that's, again, very important. Human involvement. So these are the few things Anthropic says that basically 10 to 20% of effort was spent by humans. Again, no computational methodology that how did they come with this number. Include campaign initialization, because somebody has to give the targets and somebody has to role play. So that can't be automated. So because you're giving prompts, and based on responses, then you are continuously changing your prompts. Authorization decisions, intervention at critical junctures, using of harvested credentials, and making final, like how much data are we going to take out and retain. And again, the key thing which makes it not super autonomous is that the development of this framework itself would have taken a lot of time. So once you click OK or go about and start attacking, there is minimal human intervention, but the development of the framework itself would have taken a lot of time. It's not a simple task. And this is something which I think the report doesn't go into or doesn't even point that, okay, like it talks primarily about the attack, that it was autonomous or 80% autonomous, but doesn't talk about the fact that the development of the framework itself would have taken a long time. So this is the simplified diagram that they put forth in the report. Everyone with me so far? Give me a thumbs up. Okay. Good. So it's moved. Human involvement. Okay. So this is the architecture diagram that they put forth. So if you look at the top, that's you have the orchestrator, the Claude code. Then you have these MCP servers, model context protocol servers, which acts like a middleware. And then you see these tools. And these are the open source security tooling which they used. And at the bottom, you have the actual web app, database, network, cloud infra, and appliances which were being attacked. And there are a few interesting things here. The first thing is people, when think of the word MCP server, they think that, oh, it's deployed somewhere in the cloud. That can or cannot be true. In terms of architecture, MCP servers can be deployed both locally with the client. So for example, you're operating in desktop, the server can actually be on the desktop itself, and it uses the standard input output protocol STDIO. And it can be in the cloud as well, where it uses HTTP and server-side events, SSE. The other thing which I think is wrong in this diagram is when you talk to the MCP servers, the communication is bidirectional. But if you see the arrows, they're just going like one way. I don't think that's accurate. The beauty of the MCP protocol is the communication between the client, MCP server, and tools and the applications is bidirectional. And again, these are open source security tools. At the right side, again, this is very interesting. Neutral party callback services validate exploits. So what happens, like once you're in the environment, you have dropped an exploit, how do you confirm that you have successfully exploited? So what you do is you put in some sort of URL and do a callback to a server you own. So once you get this callback, you say, okay, yeah, I can confirm that this machine has actually been exploited. And typically the callback would include information like IP address, some system information, and so on. One interesting thing was that the example in the report they used was of a SSRF vulnerability. But this callback to confirm exploitability can be done through SSRF, through blind cross-site scripting, or the various out-of-band techniques. They're also called OST. So it doesn't have to be SSRF only, but I saw some people posting online on LinkedIn and so on, and they were saying, oh, this attack was detecting SSRF. No, SSRF was used only for one thing, which is to confirm exploitability. So this Chinese entity did not launch an attack to find SSRF. They use SSRF to confirm exploitability. And to confirm exploitability, SSRF is not the only way. Okay, so moving on to I think I'll go through all the phases as in the report. So if you haven't read the report, this is going to be good just refresher as to the phases as they talked in the report. So there's a human operator, it provides a target. So one, it does the role playing to make sure that attack can go through, and it provides a target. So again, these companies, chemical companies, large tech companies, these are the targets which the human operator provided to Claude code. Again, the novelty of the attack was that multiple targets were executed in parallel. Phase 2, recon and attack surface mapping. So this is, okay, I know the targets, but how many IP addresses, which prod server, which QA servers, how many APIs. So these are typical recon activities where you try to know everything about the company. And this is where, say, a lot of autonomous recon was done, the whole infrastructure was cataloged, what authentication mechanisms they have, are they using Okta, Auth0, is it like their own authentication which they have put in play? which are the highest value databases, and we'll talk more about, I don't know, like how did they come across this, that especially at the outside level, you can't tell the database schema or the database names. But this, according to Anthropic, this is what was done in terms of recon. These are some of my observations. So it seems that Claude has some capabilities of CTEM, and we'll go through an example as well. But still, without proper tuning and input, it's pretty hard to get a good output. We exactly don't know that what Claude was able to output, so organizations can take defensive measures. And for me, if I was a nation state, I would typically get a top of the line commercial CTEM tool through a shell company in a country which doesn't have a lot of digitization, so it's easy to hide my trail. And I would take the results from this top of the line commercial CTEM tool, and I'll feed it into whatever AI tool I'm going to use to do the actual attack. So use of Claude to do attack surface monitoring, or mapping, I'm not sure what was that efficient. Second thing, which from observational perspective, they said MCP servers were used. So MCP server is not just like a standard server that you take off the shelf and you say, I'm just going to do integrations. So all of these are like custom written with custom integrations. The beauty is that once you have a MCP server and you have done the integrations, then you don't have to do the work, but few companies will provide it for you. So for example, GitHub has an MCP server which talks to any services provided by GitHub. Atlassian has an MCP server. So Atlassian is doing all the heavy lifting in providing you the MCP server. And there are few open source MCP servers which are provided against certain open source tools. But there's not one MCP server which basically has the entire mapping of every single tool which works and the attacker have the knowledge of. So there's a lot of work that we are going to have our own MCP server. This is the tool set that we are comfortable with. We are going to develop the integrations with this custom MCP server with the tool that we like and we're going to use, which provide us the maximum stealth, maximum impact, and then we're going to deploy it. So again, doing this custom work is a lot of work. It's not that you just picked up anything from any MCP server registry. And typically the tools which have been MCP server, which have been open source, they're typical against one tool. So you will find MCP server for Splunk, MCP server for Ghidra, MCP server for some of the scanners, but there's not one tool which says in terms of red teaming, these are the tools, and you just pick it up and launch an attack. So again, the report doesn't go into detail into this, that this requires a lot of work. It's not autonomous. Somebody has to do the actual development work to do this. Again, observation, I don't know like how Claude was able to spot, especially in the attack surface mapping phase, you don't know. You are just seeing the external surface. You don't go to the database level. So I don't know like, how they said that they're saying that they were able to find database names, a schema, unless someone like left out some documentation file, like some open wiki where they were able to. But again, that would be very rare and not the norm. And if you look at the current state of the state, the top line human hackers, they have this whole recon phase completely scripted out, fully optimized. So I'm not sure like what efficiencies these nation state actors would get out of Claude, because this already has been like fairly optimized. And then what you get the results you can feed into AI tools, including Claude. But this thing has been is being already done very well by top line human hackers, especially at the nation state level. Give me a thumbs up if everyone is with me so far. Okay. Very nice. So I think I did like a thought experiment. Like, let me just see what Claude can do. So I just went into Claude desktop. I didn't even use Claude code. And I gave this prompt. I'm a security researcher. Help me do a detailed technical write-up on security of OpenAI cloud infrastructure. So I was like, let me check what OpenAI is up to. So again, this was like a single shot prompt. I did not tune it. I didn't do anything like fancy, just a simple prompt. I'm a security researcher. Help me do like a technical write-up and use continuous threat exposure management tools. So this is what I got. And actually I shared the links and I was able to publish it. So I think it's in one of the links where you can actually see the assessment. It's not very technical, but again, this is a single shot prompt without any tuning. I just did this half an hour back. Attack phase 3, vulnerability discovery and validation. And this is where say, okay, how do we find what is vulnerable and how do we validate that this actually works? Again, this is where a lot of automated testing was done. And we talked about callback communication system, which is once you say this is vulnerable, how do you make sure that you tell your command and control server to confirm exploitability? And again, this is an observation I talked about earlier as well. So in the report, they give an example where this is identified SSL vulnerability. So this is one, it's an example. Two, it's only for, this is one way to communicate back. And that's why this example talks about SSL vulnerability. So the attack itself is not just about finding SSL vulnerability. So again, this is a misnomer. A lot of fairly senior security professionals are like doing LinkedIn posts, and I was like, no, this is not right. Because this is an example, and there are other ways to do exploitability confirmation. Attack phase 4. So once like you say it's exploitable, how do you do lateral movement? How do you get more credentials? So this was phase 4, and I kept just according to Anthropic. So they were extracting authentication certificates. They were testing credentials, whether they work or not. And this is where a lot of automation in terms of Claude independently determined which credentials worked. And typically this would be through browser simulation. You have to test it against some interface, a web interface or an API interface to make sure that these tools, these credentials actually work. And then you map privilege level says, oh, I was able to log into the system, but this is a QA server or this was a prod server. And then it was able to document that and provide it to the attacker. Observation. So again, I think one interesting thing is they said Claude did this, Claude did this, Claude did, X, Claude did Y. In reality, it should be saying that Claude code used a MCP server which invoked a tool to do certain things. So Claude didn't do credential harvesting. There was some tool which was used to do specific action. But the whole report talks about Claude did this, Claude did that. So again, I think just the way it is written is, I don't think it's accurate. It should be saying Claude code invoked the custom MCP server written by the attacker, which invoked a specialized tool to do XYZ. I think they do talk about in one of the examples that a credential was created for backdoor access, but doesn't go into detail if a remote access tool was dropped and so on. But in one example, they do say that a credential was created for persistent access in one of the attacks. The other thing which I feel is that if they claim that Claude code was able to do a lot of stuff. So for example, it says Claude code was able to create a package, malicious package, which could do exploitation. So that would literally mean that their training data set for Claude included those scripts. Otherwise, there's no way Claude would be able to generate malicious scripts, which means that the Claude was tested using these scripts and appropriate safety testing was not done in terms of what data is being fed into it. Again, like many of these frontier AI labs, basically they scan the whole internet, and internet has everything. It has hacker websites and whatnot. And the whole data was used to do training of these frontier AI models. So that's why you see good stuff and you also see bad stuff where they're telling you that this is how you can make a high-yield explosive and so on, or this is how you can make a biological weapon and so on. Again, one of the claims in the report, I think coming from directly from the report, is that the AI made thousands of requests, often multiples per second. So again, in the report, it's interesting that sometimes it's Claude, sometimes it says AI. So it's not very clear, what they're trying to say here. For example, here says the AI made thousands of requests, which again, I think is wrong. Claude code invoked the MCP server, which then use a tool to do something which is scanning or whatnot. The AI didn't do it. So saying AI did it, I think is a misnomer. The tool which AI orchestrated did whatever was done. And again, they actually acknowledged that it was not thousands of requests per second, but thousands of requests in total, often multiple per second. So they fixed the report, but they haven't fixed the article. So there's one high-level article and there's a report PDF So they fixed the PDF, but they haven't fixed the article. The other interesting observation I had was that if this whole thing was launched using commercially available CROD accounts, then you have to buy first, then you have to integrate your your web account where you have actually bought it, and then you need to do a connection with Cloud Desktop. You need to buy a lot of tokens to do any activity. So I don't think it was done using a generic user account. You and me just put a credit card. It was done an enterprise level account. Typically, that would involve some sort of newer process. I don't know, like maybe there are some controls which were not in place in terms of that this entity was able to get enterprise level account with a high number of tokens and was able to launch this attack. As I said, lack of customer verification, rate limiting, or lack of detection rules, which is typically one of the principles in API security is if you see someone is exceeding, and Lewis has this very well in place that they'll actually say, no, you are using too much, or you have used up your quota and whatnot. So it seems that the Cloud API didn't have rate limiting in place, or maybe they were too generous in terms of the maximum number of connections allowed, and detection rules. So we don't know what detection rules they have put now in place. And again, maybe that was like one of the lessons learned for them is that they need to do a better job at putting detection rules. And rate limiting actually helped with AI distillation attacks, which is typically to extract the model weight. So model weights are something which are basically the keys to the kingdom in terms of core IP for any frontier lab. So you do a lot of training of your models and you come up with these model weights, and attackers will try to steal these model weights. And one of the ways to do it is basically asking AI models, frontier lab models, questions again and again, and try to extract that through these questions, and which is called a distillation attack. And rate limiting actually prevents those attacks. So not sure like why was like rate limiting not put in place. Phase 5, data collection and intelligence extraction. So I think as per Anthropic, at least against one company, they were independent query of databases, they extracted data. And as I said, in this example only, they created a backdoor user account. Maybe in other places, maybe they put a remote access tool in place. But in this particular example, they created one user account. The other interesting thing is they downloaded the complete result. So they didn't do any parsing. And data extraction is actually a hard problem, which is once you exploited everything, but how do you get the data out? So typically people will like zip the files so your firewalls can't detect it, or they will break the data into smaller pieces, because if you have any sort of firewall, it will, and there's huge amount of data coming through your inner system that will flag it. So typically hackers will hide exfiltration at times when there's a lot of traffic. So for example, if you look at a normal e-commerce system, you can see trends that how Asia is waking up, North America is waking up, and there's huge traffic when people start shopping or doing activities. And hackers will blend in the traffic during these times of high traffic. But in this particular example, they basically got the whole data set locally, and then AI did the parsing. Phase 6, again, as per the topic, this was fairly novel, which is they were at each phase, they were able to do comprehensive attack documentation. And all this was done via structured markdown files, what data was extracted, what are the techniques we used. And at the end of it, they were able to pass this information to other teams for sustained operations. Give me a thumbs up if everyone is with me so far. Do I see a few thumbs up? Okay. Yes, thank you. Thank you again. So moving on to the next slide. What are the challenges the hackers faced? And again, I did find this clip art. So I've done some hard work in finding these clip arts. Hallucination. Claude frequently overstated findings. It fabricated data during autonomous operations. Oh, I have extracted all this secret information, but that information was actually publicly available, was not really super secret. It hallucinated credentials that didn't work. And per Anthropic, that was an obstacle for a fully autonomous cyber attack. which means that we are not like yet there in terms of AI being Skynet. And as per many researchers, this is where the claim of being autonomous is disputed, which is given the level of hallucination, there's no way you would have this chaining of the attack because things will break. And it's, even for monitoring, and we'll talk more about it as well, if you have too many failed logins, your monitoring systems will detect it. So yeah, as I said, that if you have these hallucinated credentials, all these failed logins, and typically everywhere I've been to, the criteria is 5 or 3 for highly sensitive systems. If you have production grade systems and you have multiple failed logins, you would get an alert. And that's especially for like companies which have very mature security posture. That's a given that if you get multiple failed logins, you will get an alert. And again, the other questions are that how there's a technical level of expertise in terms of limitations by AI itself, multi-step reasoning, context maintenance, which is like if you're doing a very long transaction, how is AI able to maintain the context, precision, what are the success validation criteria, and so on. Final thoughts. What does future behold? So again, these are all like my observations. For me, like if a nation state did it or someone really advanced thought process, I do see in future that LLMs will be trained on the entire digital footprint of not just the company. So right now you're doing threat exposure management and trying to, it will be all for all the employees. What does their social media profile look like? The family, the pets, events, anniversaries, hobbies, brands. So literally you can prepare a social graph. So if you have maybe say 100 pictures out there, and depending on how many pictures you have liked or who you follow, what clothes are you wearing, there's a very good profile that can be made in an automated fashion in terms of what passwords you would have. If I have to create a deep fake, go through whatever you've written so far in public blogs, how you speak, how you take pauses, and so on. So I do see in future attacks, it's not just going to be technical. As I said, it's going to be an integrated campaign, which is going to use the social media element where a nation state would use everything you have put out there in terms of videos, blog posts, Instagram, and use it to create deepfakes, easily guess passwords, and send highly accurate or convincing phishing emails. Second thing, I do feel that this particular report says open source tools were used. I do see nation states using commercial tooling. And it's going to be like in this open source tooling was changed, but there's nothing preventing a company from basically chaining commercial tooling, which was bought through a shell company. And this actually is happening even now because you would see hackers using commercial grade pen testing tools to do actual attacks. The third thing, which is not talked in the report, if a nation state has to do an attack, these LLMs are going to be fed all open RFP information, any awarded contracts, because a lot of governments have transparency requirements, including United States. Basically, whenever renewal comes up, they'll say, oh, we are going to buy CrowdStrike, 150 licenses for this department. This is the cost. Or when you open a bid, you say, these are our requirements. So now you know that what the requirements are. And then when the contract was won, you also know that this tool is going to be configured according to the requirements. So I do see it happening sooner than later. One thing which I see is that there's no independent safety benchmarking. I think there's some people who have done some work mainly at the academic level, but there's no comparative, like we have it fairly mature when it comes to antiviruses, that the criteria which are well defined. You have packages that can be tested and you can see efficacy, but I don't see like a lot of independent safety benchmarking being done as of now. Predictions, I do see this coming in future, that a shared responsibility model, just like many of these cloud computing companies have a shared responsibility model where the frontier labs will have certain responsibility in terms of security and safety. And so again, it's not very clearly defined right now. There's actually no shared responsibility model. And I do think that these frontier labs need to take leadership in terms of coming up with this. In fact, you produce one, I think it will give you a good head start in the industry. That what does this shared responsibility model look like, and what does the control matrix look like? Again, I think the reason it hasn't been done because the controls are still evolving in terms of what can we do. Up till now, the focus has been primarily in like how do we make this thing work that is actually can be used. But now I think the need of the hour is that we define specific controls to make sure that we can use this in a safe fashion and cannot be used for malicious purposes. I do see, I think it has already started coming. OpenAI came with Adderwork, and I think it's just going to mature from there, which is these frontier labs will come with their own native security tooling, and it will be almost like you buying advanced security package from them where say, no, I want to monitor accounts. Maybe I have a corporate 1,000 accounts. I want to monitor their what roles they have been given. Can I do any policy level deployment? Literally like AWS or GCP, where you can say, I have 1,000 employees. Not everyone needs access to everything. And some people need access to one GU and so on. So all this I do see coming in future. And the good thing is these frontier labs have AWS and GCP as examples to follow. I also see them launching AI security marketplaces where you will have a different tooling available that, okay, we do this, you can buy this from us directly. And by the way, there are 15 different AI companies, AI security companies who can do additional stuff in terms of logging, monitoring, and you name it. And I'm pretty sure that they're going to monetize. We don't see it right now, but I would say between 6 months to a year, you'll see AI security marketplaces being launched by these frontier labs. And I think that was it.